There are actually many different definitions of acids and bases, but one of the most comprehensive and useful definitions for us is the Bronsted Lowry theory of acids and bases. And basically, what this theory states is that acid-base chemistry is defined by the transfer of a proton. Now, we learned way back when that a proton is just a subatomic particle, but actually, H plus is a proton. It has no electron, it has no neutron in general, and has an atomic number 1. So when we say H plus, we refer to that as a proton. So acid-base chemistry is all about this proton transferring from one chemical to another. Now, the chemical from which the H plus comes from, that is the chemical that donates the proton, is known as an acid. And the chemical that accepts that H plus is known as a base. So let's take a look at a chemical reaction and kind of see how this works. The first thing we're going to look at is an acid dissolving in water. And any time an acid dissolves in water, it does what acids do, it donates a proton. And the only thing that it can donate it to is a water molecule. And water is actually quite happy to accept a proton because oxygen has 2 lone pairs. Bronsted Lowry bases must have a lone pair to accept a proton. And a Bronsted Lowry acid must have an H that can be donated as a proton. Not all hydrogens can be donated. This hydrogen has to be bonded to an electronegative atom, which is usually oxygen. In this case, we can see it's chlorine, but it's still, chlorine's electronegative. So what happens when we put an acid in water? Well, this hydrogen is originally covalently bonded to chlorine. Remember, this line here means 2 electrons are being shared. Even though it's a line, it still means that 2 electrons are being shared. And when this acid comes in contact with water, the acid will donate a proton. This proton, this H plus, a hydrogen without any electrons, gets transferred to a water molecule. And one of the lone pairs on that oxygen atom of water will share with the hydrogen that has no electrons. So whenever an acid is dissolved in water, hydronium is always formed. Hydronium has 3 hydrogens, one of which came from the acid, and the oxygen only has 1 lone pair now, since the other lone pair is now tied up in a bond. So anytime an acid dissolves in water, hydronium forms, so 3 hydrogen, 1 oxygen, as well as a positive charge, and what's known as a conjugate base. In this case, it's chloride. What a conjugate base is what's left after that H plus is donated. Now, we'll review this later, but a conjugate base always has 1 less proton than the acid. So if we look at HCl, chloride has 1 less H plus, it's a conjugate base. If we look at ammonium, NH4 plus, the base will have 1 less H plus. So not only does the base have 1 less hydrogen atom in the formula, its charge also becomes more negative by 1 because it's losing an H plus, not just an H. So conjugate bases have 1 less hydrogen and their charge also becomes more negative by 1.